All right, so today's notes are going to be over one-step inequalities. Now, here's a warning. If you are having trouble with one-step equations, you may have trouble with this as well. So that means you need to make sure you are coming to tutoring when you are not understanding something. All right, so before we talk about one-step inequalities, let's talk about the different symbols we will see. So in elementary school, we were introduced to two symbols, and we need to know how to read them. So this first one I have here is a greater than symbol. So I would read this statement as x is greater than 5. And the other symbol we are used to is the less than symbol. So I would rephrase this as x is less than 5. Now, we have two new symbols that we are going to talk about. And I want you to ask yourself, what is different about these symbols? So hopefully you mentioned the line underneath the inequality sign. So basically all we have done is taken, for example, this first one, a greater than sign and an equal sign, and we combine them. So this symbol is known as greater than or equal to. So how I would read this statement is x is greater than or equal to 5. Now what that means, above, we have x is greater than 5. If I replace the x with a 5 and write 5 is greater than 5, is that true or false? Hopefully you said that is false. Now let's look at an equal sign. What if I had 5 equals 5? Would that be true or false? That would be true. So that greater than or equal sign means x can be 5. And we could say 5 is greater than or equal to x because of the line on bottom. So basically, using this symbol, the x, the variable, all right, can be included. So this means 5 here can be x. All right, so that means the last symbol, if this was greater than or equal to, this one is going to be less than or equal to. So we would read this last statement as x is less than or equal to 5. So now let's take a look at some examples of using these symbols. So the problem says, the first one, Jessica spent greater than $5 at the arcade. So think about what numbers we should use. Hopefully you said to include anything greater than 5. Okay, so in this situation, our inequality sign would be a greater than sign. The next one, fewer than 6 people rang the bell on the mallet game. Our keyword here is fewer than, so that means we have to have less than 6. So this is going to be a less than sign. The next one, there are at least 8 lemonade stands. So take a moment, think about that. So the question here is, can there be 8 lemonade stands? If you said yes, you are correct. So with this situation, we are going to include 8. So since I'm including 8, which means equal, and it can be greater, this is going to be a greater than or equal to sign. And the last problem says there are at most 12 different flavors of taffy. Well, at most 12. That tells me there could be no more than 12, but I can have 12. So this is going to include 12, and it's going to be less. So 12 or less. So this is an example of less than or equal to. All right, so now let's go through. We'll discuss more about the word problems later on, but hopefully from the previous slide, you were able to get an understanding of what the signs mean. All right, so just like one-step equations, we have one-step inequalities where our goal is to get the variable by itself. For addition and subtraction inequalities, we are going to use inverse operations to solve, just like before. So if I see addition, I need to use subtraction to get rid of it. So if I see a plus 8, the opposite would be to do a minus 8. Same thing, if I see plus 2.3, the opposite is to do a minus 2.3. Inverse of subtraction would be addition. So if I see a minus 4, I'll need to add 4. If I see a minus 5.7, I need to add 5.7. All right, so let's take a look at an example. So with one-step equations, I asked you to do something very specific, and that was to draw a line down the equal sign. That process is not going to change. Instead, we're just going to draw it down the inequality sign. And we're going to approach this just like a normal equation, except now we have inequalities. So first one step says to circle the variable, which is x, and see what's happening. I see plus 3, so step 2, I need to do the inverse, which is to subtract 3. And I will do that to both sides. The 3 is canceled, and I'm left with x. And step 3 is to solve and check. So now 4 minus 3 gives me 1. And be very careful. Instead of me bringing down an equal sign, I'm going to bring down that inequality sign, so it's going to be less than. So we would say for our final answer is x is less than 1. Now, let's talk about how to check our answer. So before, we would just plug in whatever x equaled to see if it was true. Inequalities, we cannot do that, okay? With inequalities, we have to look at our rule, okay? So our rule is technically x is less than 1. So I can use anything less than 1 for x. So an example is 0. So I can say 0 plus 3 is less than 4. 0 plus 3 gives me 3. And 3 is less than 4 is a true statement. So that tells me the rule we had was correct. Remember, with this situation, you don't just put 1 as your answer. It has to be x is less than 1. All right, so the next example, x minus 5 is greater than 7. Same thing, draw my line down the inequality sign, circle my x. I see we are subtracting 5, so I must do the opposite, which is to add 5. My 5's cancel, so on the left I have x is greater than 7 plus 5, which is 12. So as you can see, this is a very similar process to equations. The only difference is instead of using an equation sign, we are using inequality signs. All right, so now I have 4 problems for you to try on your own. Go ahead and pause the video, and when you're ready, you can press play to check your answers. All right, so for the first 3 problems, check your answers with mine. Hopefully you got the correct thing. Now, I did not go through the last one because I wanted to point something out. So we are used to circling our variable and looking at the sign that's there. However, this one's different because I have a plus sign and then I have a negative number. So my question to you is, should I focus on the plus sign or the negative? If you said we are focusing on the negative number, you are correct. So since it's a negative 3, the opposite would be a positive. So I'm going to add 3 Because remember, in order to cancel out, I need a positive and a negative, or an addition and subtraction. So now I have t is less than or equal to 10. All right, so now we're going to move on to multiplication and division equation or inequalities. So our goal is still the same, to get the variable by itself. We are going to use inverse operations to solve. If I see multiplication, the opposite is division. So if I see 5x, remember that means multiplication, so that means the opposite would be to divide 5. Now we talked about how sometimes we're not going to see that division symbol, so we're going to use that fraction bar. So I have to get used to seeing something like this, okay, where I use that fraction bar as division. All right, and if I see division, the opposite is multiplication. So if I see divided by 9, I would have to multiply by 9. Same thing, here's that fraction bar again, divided by 6, so the opposite or inverse would be to multiply by 6. All right, so let's take a look at our multiplication division problems. So as of now, we're going to do the same process. Draw that line down the inequality sign. All right, circle your variable, see what's happening. I see multiplication, so the opposite is division. So I will divide both sides by 3, and I will get x is less than 5. On the next problem, same thing, draw my line. I see division, so the opposite will be multiplication. And I'm left with x is greater than 21. Now, multiplication and division is not always going to be the same process, okay? Here it is, but we have some examples on the next slide where we have to add a step in. So with inequalities and with multiplication and division, we have to know when is it the appropriate time to flip the sign. What I mean by flip the sign is, if I have a greater than sign, if I flip it, it'll then become a less than sign. So here's when we use it. When the inverse operations involves a negative number, you must flip the inequality sign. So I tend to like to do this at the beginning, so that way I can make sure I do not make the mistake. So what I mean is, step 1, circle the variable, determine what's happening with it, okay? Is there a negative number attached to your variable? Okay, so if I look, there's a -7. Okay, so yes, there is a negative attached to my variable. So I'm going to make a note that I need to flip this inequality sign. So at the very end where I would write my final answer, I'm going to go ahead and flip that sign and make it greater than. Now I can approach my problem like normal. I see multiplication, the opposite is to divide, so I need to divide both sides by -7. So I have y on the left, and then 49 divided by -7 gives me -7. So this would be my final answer. Now, if you're wanting more detail as to why we flip that sign, you can always come to tutoring to find out. Okay, it's a little confusing, so I don't want to talk about it now in the notes. All right, let's look at our division example. So ask yourself, do I have a negative number attached to the variable? Well, here's my variable, and it's being divided by -10, so the answer is yes. So this is going to be a situation where I am going to want to flip my inequality sign. So instead of writing greater than or equal to for the final answer, we're going to write less than or equal to. And now I can approach like normal. I see division, so I'm going to multiply by -10. So I have W left over. And 12 times -10 gives me -120. I want to make sure, did I flip my sign from the original? The answer is yes. So that is going to be my final answer. Now, what we're going to have to get good at is to determine, am I going to flip the sign or not? So I'm going to add one situation in, and it's going to look like this. So ask yourself, would I need to flip my sign? If you said no, you are correct, because there is not a negative attached to the x. It's over here by itself. If it's on its own, you don't need to flip the sign. It's only if it's attached to the variable. Same thing if I had division. Let's say x over 3 is less than 15, -15. Because that negative is on its own, I do not have to flip the sign. All right, I have 4 problems here for you to try on your own. So go ahead and pause the video. We'll check your work with mine. All right, go ahead and check your answers with mine and see how you did. So the only 2 inequalities that I had to flip were the bottom 2. And the reason I had to flip them was because there is a negative attached to the variable. This one up here, I did not have to flip. Even though there's a negative here, there's not one attached to the variable. All right, so here's an example of a star question. It's asking which inequality is true if p equals 3.4. What it means is, instead of writing p each time, I'm going to rewrite this as 3 times 3.4 is less than 10.2. So I need to see when I multiply it together if it gives me a true statement. So go ahead and try this one on your own. All right, hopefully you paused the video. If you went through and solved all these, I'm going to run out of the room if I did do that. You should have gotten J as the correct answer. All right, so you will not have an assignment today over this, but you need to make sure you practice, okay? What we've seen a lot of people struggling with is combining integers. So in a situation where you have like -15 plus 5, okay? We need to make sure we are practicing on our own. And remember, if you have questions, you need to come to tutoring.